Imagine a world where everyone can create their own ideas and collaborate with anyone, anywhere in the world to solve the problems of mankind. Today, I will be sharing about advanced bayanihan manufacturing and our production of Stopgap PPEs during this COVID-19 pandemic. John F. Kennedy quoted that the word crisis, when written in Chinese, is composed of two characters. The first one is danger, and the second one, opportunity. He suggested for us to be aware of the danger, but to also recognize opportunity. The Spanish flu from the last century, and now the COVID-19 pandemic, has endangered and has taken millions of lives. The ADB reported that millions of PPEs are required each month, and in order to help, we found an opportunity to act and contribute to our fight against COVID-19 by 3D printing PPEs. 3D printing, more formally known as additive manufacturing, is basically the layer-by-layer adding of materials until a part is formed or created. It is also related to the terms direct digital manufacturing, solid free-form fabrication, and rapid prototyping. It promotes smart manufacturing and thus enables the fourth industrial revolution. These videos show PPEs being produced in our laboratory. How does it work? 3D printing starts with a CAD model, and then you slice it into hundreds or thousands of layers, and then you 3D print the part. The most common 3D printing technique, which is the fused deposition modeling, is similar with the principle of a glue gun, where a material is melted by an extruder, and the part is created by the layer-by-layer adding of materials following the CAD model. Last year, we inaugurated our laboratory, which is the country's first 3D printing research facility. We focus on advanced materials, applied mechanics, academic makerspace, advanced modeling, advanced manufacturing, and advancing manpower. For our activities, to support our frontliners, we used 3D printers and injection molding machines. For the materials, we used 3D printing filaments and resins, as well as pellets for injection molding. We were able to produce PPEs such as mask flanges, ear guards, door pulls, and face shields, and distributed to local hospitals and businesses. We used the term stopgap as our main purpose was to fill the gap or shortage of PPEs during the initial months of the COVID-19 pandemic. It should be noted that these products are not meant to permanently replace the conventionally produced and approved PPEs. With our efforts, we helped protect at least 3,000 lives from COVID-19. We have also advanced the science and technology of 3D printing through presentations and publications. As an example, we were able to write and publish a paper regarding the use of 3D printing to produce PPEs during the COVID-19 pandemic. We collected all information on 3D printing activities from all over the world. This is an open access article and is one of our main contributions for the COVID-19 pandemic initiatives. We observed that the following must be considered moving forward. The first is the establishment of 3D printing farms, such as the one that we have in BPSU. The second is adoption of hybrid manufacturing using 3D printed molds for injection molding. Our activities for hybrid manufacturing were results of earlier research published last year and this year. This hybrid manufacturing is a process flow that is quickly gaining attention. In our paper, we also suggested a new framework, what we call the distributed and cooperative additive manufacturing. It is a framework where everyone can print and participate. Of course, standards and government regulations have to be satisfied. Others call it citizens' supply chain, but in BPSU, we call it advanced bayanihan manufacturing. Using these capabilities and processes, we were able to distribute PPEs to the community. The bayanihan spirit is very much alive with our partners, donors, and supporters, donating equipment, materials, time, and effort. We appreciate the help of all volunteers and supporters, especially DOST. BPSU is now transitioning the laboratory into the Dream Center and will continue to be relevant in today's advanced manufacturing research and development. With this facility, BPSU will be more ready to combat any disaster, pandemic, or any eventuality. I am encouraging the government and business sector to invest more on 3D printing and advanced bayanihan manufacturing, as well as for students and the community to learn this new manufacturing process. Let us all take control of our future by using this technology that is already within everyone's reach. Join us as we create a better and brighter future for the Philippines, one layer at a time.